So if I have this product, so now our base isn't just a single term. Our base isn't just a single number. It's a product of two factors. It has a 2 and an x. It's 2 times x is our base. So when you look to apply a power to a product, that power is going to apply to each individual product. Okay, now, lots of times students will refer to this as the distributive property because this power of 3 is applying to the 2 and it's applying to the x. Okay, try not to, because distributive property has to do with multiplying through a sum, and there's no sum here. It's a product of terms. So if you just think of this, power is going to apply to each factor. So you first have to identify your factors. We have a factor of 2 and a factor of x, and each of those factors is going to receive the same power. So this power of 3 applies to the 2. The power of 3 applies to the x as well. And so when you expand that out, you can simplify 2 cubed. And does anybody know what the value of 2 cubed is? 8, right? 2 times 2 is 4 times another 2. Again, remember, this really just means 2 times 2 times 2. So you have 8, and then x cubed would stay in that form. All right, what if I gave you something like this? 5y quantity squared. What is that going to equal? Identify your factors. Our factors are 5 and y. Apply the power to both bases, a base of 5 and a base of y. And if you can simplify 5 squared, it's 25. Y squared stays as it is. And now let me compare this to something that's really close. 5y squared. Okay. What does that power of 2 apply to? What is the base for the power of 2? Harrison? Just the y, right? And remember order of operations. Okay. Order of operations, you guys remember this saying? And you do parentheses or any grouping symbols first. There's no grouping symbols. Then you do exponents. Okay. The exponent is this expression, this part of the expression. It's a base, a power, forms the exponent. And this 5y, 5 times the y squared is multiplication. And you see that comes after you apply the rules for exponents. So when you simplify this, it's just 5y squared, right? There's nothing else that simplifies. And what if I did the following? Okay, what is the quantity negative 3y all to the 4th? Do you have a product that your power applies to, or does it apply to one single base?
Whatever 27 times 4 is.
Yeah. So you have a negative 3 and you have a y, right? So if you think of this as this power of a product rule, you can take your base of negative 3 and you can take your base of y, identify each one and separate it, apply this power of 4 to each. Okay, and now when you look at this, break this down. If you can mentally picture, this is negative 3 times negative 3 times a negative 3 times a negative 3. Well, what if you group these? What is negative 3 times negative 3? 9. And what's negative 3 times another negative 3? 9. And so what's 9 times 9? So you have 81 y to the 4th would be your answer. Would it make sense that you start with a negative in your base, but your solution winds up being positive? Yeah, if the power is even, those negatives are going to cancel, right? And here's the easiest, or one of the ways to imagine that, is instead of breaking this into a base or two factors of negative 3 and y, you can break it into the factors -1, +3, and y. Does everybody see how you can break that? You separate it into here's one factor, here's a second factor, here's a third factor. And then apply this power of 4 to each of them. So following the same rule. And a +1 to any power is 1. A -1 to an even power is 1. A -1 to an odd power would be -1. It would stay negative. So here, -1 to the 4th is just a +1. And then you have 3 to the 4th, which we found to be 81, and then y to the 4th. And so using the identity rule of multiplication, meaning multiplying by 1 doesn't change the value. So you have 81 y to the 4th as your solution. So the general rule for this is if you have a to the m, if you have the product of a times b all to the m power, okay, you have a power of a product here, you're going to split the factors of your base. You're going to apply your power to each of those factors, and that's the simplified form. And this is the power of a product rule. So those are the three that you need to be aware of. All right, so see if you can identify what this simplified form would be. All right, what's the base of our exponent? Here's our base, right? Is the negative part of that base? Does the power of 2 apply to the negative? No. The negative is outside of the parentheses. So we're going to look here. We can split this into our two factors. Okay, so we have a 3 and a y. This negative is still going to stay out front. And then apply this power to each of these factors of our base. So 3 squared, y squared. And so when we simplify what we have here, we still have our negative. 3 squared is 9, y squared. So we get a negative 9y squared as our quantity. Okay, what if I did this? What's the answer going to be here? The answer would be 9. You could either think -3 times -3, or you could split it using the power of a product rule. You have two factors, a -1 and a 3. So if you take a -1 and you take a 3, apply the power of 2 to each of those. -1 squared is just 1, 3 squared is 9. So that's going to give you your answer of 9. All right, so let's take a look at how you would use your calculators for these. It's pretty self-explanatory. I just wanted to make sure you understood, or at least were exposed to, why the rule works or how it works without using the calculator for it. And so if I gave you something that looked like this. If you're going to enter this in your calculator, okay, usually you can just follow exactly the rule that it shows. So parentheses, 3x, close the parentheses. This caret symbol right here above the division represents to the power of. Choose 4, and when you hit enter, it simplifies. 81x to the 4th is what your answer would be. And now, what if you wrote 3 to the 4th, x to the 4th? Would that be correct? Is that the same thing? Yeah. Okay. So make sure you can identify both of these. It is possible And that on a quiz or a test, if I gave you like a matching type of problem, that I might leave it in this form rather than this one, simply because your calculator doesn't give you this form. Okay. I'm mean like that sometimes. Okay. So be prepared for that, which is why I wanted you to understand like why or where these things come from. Okay. Evaluate this.